Welcome back, student, to part 1 of Stokes theorem in Calculus 3. Today we will solve some examples about the Stokes theorem, which will give us the relation between a line integral over a boundary curve to the surface integral over a surface S. So the first question for part 1 is we need to find the surface integral of the curl of f dot ds, but here he emphasized to use Stokes theorem. So we have the vector field, and I have a surface which consists of a half of ellipsoid that lies to the front of the YZ plane, oriented in the direction of the positive x-axis. We will see about this orientation, but the first thing is let us state what Stokes theorem is telling us. Stokes theorem saying that this double integral is equal using Stokes theorem by the single integral over C f dot dr. So what we need to do here is we need to find the boundary curve C, and then we need to find the derivative of the parameterization. So my goal is to find a parameterization for this curve C, and then we find this integral. So in order to find the parameterization, let's have a quick sketch of the surface S here. So this is the y plane, this is the z plane. Remember, the x is the axis that goes outside from the screen. Now this is half ellipsoid, and this half ellipsoid actually going outside the screen. So it will be something like this. Like this. Now this is the general shape for our surface S, and now we need to find the boundary. If you can see, the boundary will be here in the YZ plane, which is kind of the entrance for the surface S. So we need to focus on this one, and in order to find that, we have to set x equal to 0. So parameterization of the curve will be given by this one here, z, y. Of course, the first thing is for the parameterization is that x equal to 0. If x equal to 0 and we substitute 0 here in this equation, what we will get is 4y squared plus 4z squared equal to 4. So this will give me this equation. 4y squared plus 4z squared equal to 4, which of course I can reduce it into something familiar to me, which is divided by 4 will give me this one, and this one I know it, this is just a circle of radius 1 centered at the origin. So if we just sketch it here, we'll get a circle of radius 1. And that's exactly what we get. So if we want this is C, if we want the parameterization, of course the parameterization for C will be given by, first of all, x equal to 0. Now, if you remember, if we have y squared plus z squared equal to 1, one of the main parameterization and the easy one to use in this context is to use y to be the cosine t and z equal sine t. Of course, here t will be between 0 and 2 pi. Of course, we can check if we substitute y here and we substitute z here, the answer will be 1. So this is a good parameterization. It will cover the whole circle. Now, once we have the parameterization, we can write it as a vector function. So it will be x is 0, y is cosine t, and z is sine t. What's important for us is to find the derivative dr, which will be 0 minus sine t cosine t. And now we are ready to find the integral, because all what we have here is by Stokes theorem. If we want to find f dot dr, all what we need to do is we take the integral and transform it in terms of t. So the integral will be from 0 to 2 pi, because t is from 0 to 2 pi. Now we have to find what is f. Just let me remind you what is f. F is here. If we just take this, copy paste it, copy, and let us paste f here, so we can see exactly what we need. Now if we take the dot product, so we have to multiply the first with the first, so I need to multiply exz by 0 plus the second one will be here, which is ex, and then we multiply it by negative sine t, and the third one will be y squared z, we multiply it by cosine t, which is the first and the first, second with the second, third with the third. Of course, we have to change everything back in terms of t. First thing we notice that this one equal to 0. Now, if we substitute ex, I will get e power 0 times sine t minus sine t plus the first y will be cosine squared t, the z will be sine t, and I have from the derivative cosine t dt. Now if we just have this integral, it will be from 0 to 2 pi. The first one will be just negative sine t plus cosine cube t sine t dt. And if we find this integral would be the integral of negative sine is cosine t. The integral of cosine cube, and because of the derivative of cosine is negative sine, this will turn out to be function and its derivative. So it will be negative 1 over 4 cosine 4t, substituted from 0 to 2 pi. If we do this, the answer will be just 0. And that's how we use Stokes theorem to find the integral. Of course, we need to double check if really the answer is 0 if we find this one separately as surface integral. So we need to do the parameterization for the surface and find the integral. I will leave it for you as an exercise, but this is how it is. Thank you, and please watch part 2, which will do the opposite. In part 2, we will be asking to find this one by finding the surface integral. Thank you for watching.